In this video, we're going to explore some ways to address uncertainty. This exercise that you're looking at is available in the course materials, and I'm going to walk you through it. My hope is that at the end you'll have a comfortable feel for the difference between knowledge uncertainty and natural variability, which are the two major components of uncertainty as encountered in risk analysis. So we're going to begin with a simple exercise here. I live in Baltimore, Maryland, which is point A on the map, and I have a friend who lives in Hattiesburg, Mississippi, which is point B. Imagine that our problem is quite simple. We're trying to estimate a gasoline budget for driving a private automobile from point A to point B. So let's scroll on down and we'll begin that. The first thing I'm going to do is develop a deterministic estimate. Ordinarily, what decision makers do is they come up with their best guess. Even when they don't know things, we come up with a best guess. We come up with a single number, and we treat that number as if it's a fact. So I'm going to begin here. The distance in miles from Baltimore, Maryland to Hattiesburg, Mississippi. If I were to ask you to give me a number, we would put that in, and this would be a matter of knowledge uncertainty. Because given the route that you see on that map, there is a fixed and constant number of miles. But I'm going to play the role of a person who doesn't know that distance, so I'm going to say, let's say it's 1,200 miles from Baltimore to Hattiesburg, Mississippi. The second piece of information we need to know is what is the mean highway mileage for a 2013 Honda CR-V. So what's the average miles per gallon? Now, if that's not your car, then you don't know what that is. But I think, gee, when I think of Hondas, I think they must get pretty good gas mileage. So I'm going to assume that they can get an average of 30 miles to a gallon driving on the highway like this. Now I need the price of 1 gallon of gasoline, and I know the price is going to vary when I go from one state to the next, and so I have to come up with a guess, and that's also going to depend on the time of year and what year we're in and many other factors. So I'm going to put in $3.45 as my best guess. Notice that the green cell shows a gasoline budget of $138 with these three elements. But once again, let's go back over them. The distance is knowledge uncertainty. That is a constant. It's just a value that I don't know. The mean highway mileage for 2013 Honda CR-V is also a constant. This is another bit of knowledge uncertainty that I don't know. And the price of gasoline, this is something that just varies naturally. It varies from one time of the year, from one year to the next, from one state to the next, and so on. But using all of these, actually ignoring all of that uncertainty, I come up with an estimate of $138. Okay? And many issues are like this. Many problems are like this. We don't know the component parts. We make a best guess. We come up with $138 and we move forward as if that's truth. But what is the chance that the gas budget is actually going to be $138? And I'm hoping that anyone listening now would say that's really very small. So we're learning about uncertainty and we want to see if we can do better. So I'm going to go to a tab here that has an interval estimate. Don't worry about reading all of the words here. If you work through this exercise, they are to guide you through it. I'm going to jump right to the cell here that we want to work in, that I want to estimate this mileage as an interval now. Instead of saying it is 1,200 miles, we want to look at creating a minimum estimate. I want to make guesses about the distance, the mileage, and the price of gas such that I would have the lowest feasible gasoline budget. So in my guess, that distance is not going to be less than 800 miles. I'm thinking if I want a good, meaning a low gasoline budget, then I'm guessing the mileage for this Honda CR-V on the high end. And I'm thinking on the highway, maybe you could get 35 miles per gallon. I don't know. I'm not familiar with that particular car. And the price of a gallon of gas. Maybe if we got really lucky, it could be $3.20. Notice that this gives me a gasoline budget of $73. But I'm trying to deal with the fact that I really don't know these values. So I'm going to go up here and come up with a maximum estimate now. So I'm quite certain that the distance is not more than 1,400 miles. This maximum estimate is trying to come up with a maximum number of dollars that would be used for gas. So I'm looking for the lowest possible average miles per gallon for this particular car. And I'm going to say, suppose that's 22 miles per gallon. And now, of course, I'm looking for a high-end estimate of the price of gas, and I'm going to say $3.75. Notice that now I have the gas budget estimated as a range. I am acknowledging there's uncertainty. I'm going to say I need between $73 and $238 to pay for the gas for this trip from Baltimore to Hattiesburg. So this is one of the most fundamental ways of addressing uncertainty, is to basically say I don't know, to bound the value. You will notice that the $138, if I'm remembering correctly, from the first tab, falls readily within this range. This is not as precise an estimate. That deterministic estimate that we looked at a few minutes ago, $138, very precise, but it's not going to be accurate at all. The interval estimate is going to be quite accurate, but it's no longer precise. We're going to go to the next tab now, because you're going to learn in this course that probability is the language of uncertainty. And so what I'm going to do in this particular tab is we're simply going to estimate only the distance in a probabilistic way. So I'm going to begin here with the minimum distance, and I've already said it's not going to be less than 800 miles. My deterministic estimate must have used my best guess, so we're going to say 1,200 miles. And in the previous tab you saw I said it was not more than 1,400 miles. In this particular sheet, I've already built in a couple of distributions, so I'm going to go to the At-Risk tab, click on Define Distributions, and you're going to see here, this is one picture of the uncertainty here. Now, this is a picture of my belief. Remember that there is a fixed number here. And so this picture is basically saying to anyone who looks at it that I don't know what this value is. I think it's between 800 right here and 1,400 right here. Do you know anything else? Well, yes, I believe 1,200 right here is the most likely value, and so I elevate that. This is a PERT distribution, and in this video I'm not going to explain the nature of these distributions, but let's just say there is a mathematical function that we use to connect these 3 points, and it gives us this distribution here. Notice that there is a 90% chance that the actual mileage is between 972 miles and 1,334 miles. There's also a triangular distribution. Now I'm going to click down here and I'm going to add an overlay here. Specifically, I'm going to add a triangular distribution. This triangular distribution has the very same parameters, 800, 1,200, and 1,400. This would be another way to express my uncertainty. Notice that with the red distribution, small values around 800, 900, 1,000 are much more likely with the red distribution than they are with the blue. Excuse me. Likewise, large values over 1,200, 1,300, and so on, are less likely with the red distribution. So this is a probability distribution that is expressing my belief about what the true value is. And in this case, I'm going to go with the blue distribution. In my opinion, I think it's more likely going to be at that high end of my range than it is at the low end of my range. Okay? So now we're going to close this, and you have begun to see how we can use a probability distribution to express our knowledge uncertainty. Now let's go to the last tab, which is the gasoline budget. I'm going to put in the distances once again, 800 minimum, 1200 most likely, and a 1400 maximum. And now we're going to go over here for this mean miles per gallon. And I earlier used 22 as a minimum. I used 30 for the deterministic value, and I also said the maximum was 35. Now in the green cells below, I am using distributions, just like those PERT distributions that we used before. So these two values in this calculation, these are matters of knowledge uncertainty. They are facts. There is a rated mileage, mean miles per gallon for this car. There is a fixed distance from point A to point B. Now let's move over here to the price of gasoline. The price of gasoline is different. It's variable. It varies for a number of reasons, the time of year being one of them, the state, its taxes, and all those sorts of things. So here I'm going to say I believe the average is going to be $3.45, and let's suppose, just for convenience right now, that I have some data that tells me that's the average for the states I'll be passing through. And there's a standard deviation of 15 cents. So when I come on down here, I have a distribution here, a normal distribution. This is a picture of what the gas price could be. But this is a picture of natural variability now. If you play along with me and allow me to say that in fact the average cost of gas is $3.45 and the standard deviation is 15, then there is no knowledge uncertainty in here. This is all natural variability. I don't want to complicate this particular exercise, but I do want to take this opportunity to say that if by chance we didn't know what the mean was, or if we didn't know the standard deviation, those numbers are constants. They are also facts. And so we can have knowledge uncertainty and natural variability. But to keep this simple, let's assume I'm working with facts. Okay, so now let's bump on over to the next distribution. This is the mileage, the average mileage. So the actual mileage, of course, would vary, but the average mileage for a car is a fact. And this is a picture of what I believe that fact to be. This is a picture of what I believe the distance to be. And so here I have a gas budget that is calculated as the mileage, or let me say that differently, the distance from point A to B divided by the mileage that the car gets times the price of a gallon. And so you could see when I turn on the Monte Carlo simulation here, it could be any number of values. Now, my software that's making this video doesn't work well with the F9 key, so I have to keep turning this on and off, and it keeps reverting back to a mean value every other calculation. But let me show you this then. We can look at this cell right here in D14, and we're going to do a little simulation. I'm going to do 1,000 different calculations. Okay, that went very quickly. And here you see what the gas budget could be. The minimum value we obtained was $91. The maximum was $206. And the mean was very close to that original mean of $138. It happened to be $137.42. So now we can answer a number of questions like what is the probability that the budget will exceed $160? And you can see it's 12.2%, and so on. We're not going to talk so much about how we would use these data as this. This distribution that you're looking at right here, this spread of numbers, this is uncertainty about what that budget would be. And this uncertainty reflects knowledge uncertainty. It reflects the fact that we don't know the distance and we don't know the mean miles per gallon. And it also reflects natural variability. So down below, beginning in row 21, I've suggested we could get rid of the knowledge uncertainty by looking up the distance. It is 1,011 miles, and the CRV gets 31 miles per gallon. And so the knowledge uncertainty has disappeared. And in this distribution rate here, in D23, and I'll use an overlay for it as well, you can see that when we eliminate the knowledge uncertainty, we are still left with natural variability, but we have a much better estimate now of what the actual cost of this trip is going to be. So that if I blow this up here, and excuse me while I move the bar a little bit so you can see, whoops, so we can see the blue column here. It's going to be between $97 and $128. Why can't you give me one number? Well, one answer is because in a world of uncertainty, there's no such thing as the number. The average, our best guess, would be $112. But it's going to be somewhere between 97 and 128. That's a much better estimate now. Now that we have eliminated some of the knowledge uncertainty, that's a much better estimate than the $91 to $206. Okay? So this little exercise was to demonstrate a couple of facts about knowledge uncertainty and natural variability. We've shown you how you can handle knowledge uncertainty using an interval estimate, and that's better than a deterministic estimate. A probabilistic estimate is even better than an interval estimate. And if you can eliminate knowledge uncertainty, you can get a much better answer to whatever kinds of problems you're dealing with. So please feel free to work this exercise, and if you have questions, ask them in class.